In this segment, we will continue to work on the parent function handout. Okay, so here we are. You had filled this in last time, and one of the things that I want to call your attention to right off the bat is if I have y equals x squared, which I graphed here, right, y equals x squared. If I negate the x squared, I put the negative in front, then I just take each of these y values and negate them. Okay, so what does that do to my graph? Instead of graphing the point 2, 4, I graph the point 2, negative 4. Everything that I was graphing up here as a positive is now a negative. Okay, so what that does is it takes my graph and reflects it through the x-axis. Okay, so let's see if that's just a coincidence or whether that always happens. All right, so let's come over here and look at some other cases, and I just noticed a typo here. This should say y equals f of x. Compare each of these to the original parent function. So if you recall, y equals radical x in B looked like that. Okay, so draw a sketch of negative radical x. You can use your calculator. And then we're going to take a look at what happens if we, rather than negating the functional value, what if we negate the x? What does that do to our parent function? So we're taking all of these graphs that we're making and we're comparing to the parent function that we sketched at the very beginning of this. So please pause the video and take a look at these either on your graphing calculator or using Desmos. Okay, so if you're back after trying this, I hope you recognized that in every single case, all right, it wasn't just a coincidence what happened in the example on the last page. In every single case, when we do this, it ends up reflecting the original parent function, reflect through the x-axis, right? Because the y value becomes the opposite, all right? And we find opposite y values on opposite sides of the x-axis, okay? Over here, I hope you noticed that what happened is that at least you saw it over here in the last two, because something strange you probably thought something was strange when you did the first two. That's because, so let's see, it's going to bear with me a second. I have to stop this share and then I have to screen share, which always takes me a second to pull that up on Desmos. Okay, so here's Desmos, and I already typed it in so that I could be efficient here, but notice y equals x squared, there it is here in red. Well, I go to graph y equals negative x squared, doesn't look any different, right? So that's kind of interesting, right? I get the exact same thing. Now, if I graph y equals x cubed and then negative y equals x cubed, red graph is y equals x cubed, right? So I see that in red. What I can see that happened over here is that the function, and actually you might not be able to tell, did I reflect through the y-axis or the x-axis, right? Because I would actually get the same result either way, wouldn't I? Okay, so that's another thing that happens that's interesting. Okay, so if I were to stop this share and go back to this share, so what happens when I negate the x? What happens every single time is that I reflect through y. Okay, and these might actually have not been the best examples to show you, to help you see that, because These two, I get the same answer either way. And the reason that I get the same answer in both of these cases is both of these functions have symmetry with respect to the y-axis. If I took each of these graphs and I folded it along the y-axis, the two sides would match up. All right, and so if that happens, if I am symmetric with respect to the y-axis, and therefore I get the same answer whether I work with the original function or whether I negate the x, I get the same result. This type of function is known as an even function. Okay, so y equals x squared is an even function, so is the absolute value of x. And it has symmetry with respect to the y-axis. Okay, it's probably tempting to think, well, then an odd function must have symmetry with respect to the x-axis, all right? But that's actually not true. A function is odd, and so what we saw had happened, that happened is with this function, y equals x cubed. Like over here, I said, oh yeah, I reflected it through the x-axis, right? But then over here, I'm saying, oh no, wait a minute. I reflected it through the y-axis and I got the exact same thing. All right, and you should notice in letter D, you'd get, this would go like this, you'd get the same answer both here and here. So these two functions are known as odd functions. And what odd functions have is symmetry with respect to the origin. Okay, I could do a point reflection through the origin. All right, so let me open a blank piece of paper here and show you what a point reflection is. Bear with my not straight lines. Okay, so this comes through the origin. And what happens is I take, say, this point here. When I reflect it through the origin, right, there's its image. Okay, or if I take this point here, reflect it through the origin, which means I go equal distance through the origin, I find its image over here. Okay, so a function like y equals x cubed is an odd function. Another function that would be odd would be the cubed root of x function. Right, that would be another function that's odd. Okay, so I can either, in determining an odd function, I can either look for symmetry through the origin, or here's another way to tell if a function is odd, all right, that we just observed up above. Okay, so another way to determine that is, I'm going to say this, or you get the same graph whether you reflect through the x-axis or the y-axis. Okay, reflecting through x and reflecting through y gives you the exact same graph. That's another thing that will happen if you have an odd function. So in this next section, we're going to determine if a function is even, odd, or neither. And I am encouraging you to do this using your graphing calculator. Okay, now, and look at the graph. Do it by looking at the graph. Now, it is possible also to do this algebraically. Okay, so I can determine even and odd functions either algebraically or graphically, okay? Here's the rule for determining it algebraically. Okay, and so we will take a look at trying this. Okay, so I'll give you a second to write this down. Let me be quiet for a minute though, so you can write that down in your notes. Now, when we're working with whole numbers, every whole number is either even or odd. There's no such thing as a number that's neither even or odd, right? When we're working with whole numbers. When it comes to functions, a function could be even, could be odd, or it could be neither, right? If it has neither of these properties, right, it doesn't have to be either even or odd. So let me stop this share and let's go back to Desmos. Okay, and from the handout, you're asked to determine if 3x squared minus 4x is even or odd. Okay, so take a look. This does have, its line of symmetry, but it's over here at about, I don't know, 1.2 or something. This is not symmetric with respect to the y-axis, so it can't be even. And it's also not symmetric with respect to the origin. Okay, so it's not odd. Okay, so this first one would be neither. 0.1 x to the 4th minus x squared. All right, so take a look at what symmetry this function has. Okay, and I think it's pretty easy to see that I have symmetry with respect to the y-axis. All right, if I fold along the y-axis, these two halves match up perfectly. Okay, so this function would be even. And let's check out this one. So I had an even, I had a neither. I bet you're guessing the third one will be odd. X cubed minus 2x. Okay, so notice here I do have symmetry. Like I can see this point, if I reflect it through the origin, I get this minimum point, right? This point here, if I reflect through the origin, there's its image. Okay, so I do have symmetry with respect to the origin in this example. Or I can envision reflecting it through the x-axis, right? And then I would have the same answer as if I reflected it through the y-axis. Okay, so that's another way I can tell. But if you want to do this algebraic test, okay, so let's check out the first equation. So the first equation, I'm going to write it like this, f of x instead of y. F of x equals okay. Now check out what happens if I put if I put a negative x in place of x. So everywhere that I have an x, I put a negative x. Well, let's see what I get. I get, this would become positive x squared, 3x squared, and that would become plus 4x. Okay. This says if I get the opposite, right, if I get the negated function of x, which what would the negated function of x look like? Right, the negated function of x, here's the function of x over here. If I negate it, then it would mean just negate both parts, distribute the negative through the whole thing. So here's the negated function of x. which I did not get, so the function's not odd. And to be even, I would have had to have gotten the exact same thing when I plug in f of negative x. Okay, so let's try this on the next one. Let's see, big eraser. Okay, so the next example was 0.1 x to the fourth minus x squared. I can already tell that if I plug in f of negative x, because if I put a negative x in, but I raise it to an even power, anything negative raised to an even power is going to be a positive, right? So when I raise that to the fourth, it's going to give me positive x to the fourth, right? And when I raise this, because remember, some of you might say, oh, wait, minus minus do plus plus. No, exponents first, right? That would be subtracting before we've done exponents. Order of operations says exponents first. But again, if I square this, right, I'm going to just get positive x squared. All right, so I can already see that f of negative x and f of x are going to give me the exact same thing. Okay, so I know that it's even. And the very last example, f of x is x cubed minus 2x. Okay, so negative f of x, the opposite of f of x would be negative x cubed plus 2x. Okay, so plug in f of negative x. Well, let's see, if I raise a negative to an odd power, I get a negative. That should have a 2, and that should be a negative x. Okay, so negative x times negative x times negative x is negative x cubed. And then negative 2 times negative x is positive 2x. Okay, some of you might feel overwhelmed with this algebra. All right, I feel like in Calc 1, I need my students to have the ability to recognize even and odd functions graphically, more so than I need them to do this algebraic test. All right, so if you can look at the function on a graph and tell if it's even or odd, and for all of your quizzes, I'm going to encourage you to graph. You know, if I ask you if something's even or odd, I'll either be giving you a graph to look at, or I'll be letting you use your graphing calculator to determine even or odd. Okay, so if this algebra overwhelms you, don't panic. And so while I've still got you here, the next parent function that I want to look at, so I want to do that on this segment since I've got Desmos on my screen. But do people recognize this? All right, do people know what that would look like? And the wonderful thing about Desmos, this is what makes Desmos really nice, is on your calculator, oh, I'm sorry, stop share, new share, and now share that. Okay, there we go. What I have there is not a function, right? It's not in the form y equals. Your TI 83s and 84s will only graph something in the form y equals. So watch this beautiful thing that can happen on Desmos. It will graph that. All right, I can type that right in, and it's a circle. I hope you recognize that. And another thing that we could play around with, so it's a circle centered at the origin, the radius is 3. Okay, and we're going to review this in the next video clip. But let's play a little bit. What if I did this? Instead of just y, I have y minus, say, 3 squared. And then equals 9, same radius. So let's see which way that moves it. Okay, you probably were expecting it to move down, right? But now my new center for this is 0, 3. Here's my new center right here. Okay, so it pulls, the -3 actually pulls it up because instead of a center at 0, 0, I now have a center at x would be 0, y would be, or I'm sorry, x would be, let's see, the center is 0, and then y is 3, right? Centered at 0, 3. So let's try this. Oops, wait. X minus 2 squared plus, I'll do the same thing, y minus 3 squared equals 9. Okay, so notice what that did. Actually, wait, I'm gonna go like that. All right, so see how the +2 pushed it to the left 2? And again, this is the wonderful thing about Desmos. It's like I can play around, right? So if I change that to a +3, it moved it down 3, right? If I made this a -2, it moves it over. Okay? So we will talk more about circles in the next segment. Thanks for watching.